Which of the following is not a core assumption of naive Bayes classification? A. Conditional independence of features. B. Equal prior probabilities for each class. C. Features are statistically independent. D. All the above. Correct. Naive Bayes assumes conditional independence of features, meaning that the value of one feature does not influence the value of another feature given a class. This assumption allows the model to simplify the calculation of probabilities. Incorrect. Naive Bayes does not assume equal prior probabilities for each class. It uses the observed frequencies in the training data to estimate these probabilities. It's a core assumption that the prior probabilities of different classes are not necessarily equal. Correct. Naive Bayes assumes statistical independence of features, meaning that the features are not correlated with each other. This assumption is known as the naive part of naive Bayes, as it simplifies the model but may not always hold true in real-world data. Incorrect. This choice is incorrect because B. Equal prior probabilities for each class is not a core assumption of naive Bayes. It's a common misconception that naive Bayes assumes equal prior probabilities for each class. It actually uses the observed frequencies in the training data to estimate these probabilities. B. Equal prior probabilities for each class. This means that the value of one feature does not influence the value of another feature given a class. For example, if we are trying to predict whether a person will buy a car, their age and income might be conditionally independent given their occupation. This assumption is crucial in naive Bayes because it allows the model to simplify the calculation of probabilities. In spam filtering, the features might include the presence of certain words, the sender's email address, and the length of the email. Conditional independence would imply that the presence of a specific word in an email doesn't affect the likelihood of the sender's email address being associated with spam. Let's consider predicting whether an email is spam class 1 or not spam class 0 based on two features. Contains the word money feature 1 and contains the word free feature 2. Conditional independence means that the probability of containing the word money given that a email is spam is independent of whether the email also contains the word free. Mathematically, P feature 1 1 class 1, feature 2 1 P feature 1 1 class 1. Bayes' theorem provides a way to calculate the probability of a class given a set of features. It's the foundation of naive Bayes classification. The theorem states that the probability of an event occurring given that event B has occurred is proportional to the probability of event B occurring given that event A has occurred, multiplied by the prior probability of event A. In medical diagnosis, Bayes' theorem can be used to calculate the probability of a patient having a specific disease given their symptoms. For example, if a patient has a fever and a cough, Bayes' theorem can be used to calculate the probability of them having the flu. Bayes' theorem PABPBAPAPB, where PAB probability of event A occurring given that event B has occurred posterior probability. PBA probability of event B occurring given that event A has occurred likelihood. PA prior probability of event A. PB prior probability of event B. These represent the probabilities of each class occurring in the dataset. They reflect the overall prevalence of each class in the data before any features are considered. In sentiment analysis, the prior probabilities of positive, negative, and neutral sentiment might be determined by the overall distribution of sentiment in a large corpus of text data. If you have a dataset of 100 emails, and 70 of them are not spam class 0 and 30 are spam class 1, then the prior probability of an email being not spam is 0.770100 and the prior probability of an email being spam is 0.330100. This represents the probability of observing a set of features given a specific class. It describes how likely a particular set of features is to occur if the data point belongs to that specific class. In a recommendation system, the likelihood would be the probability of a user clicking on a particular product given that they belong to a specific customer segment, e.g., young adults, tech enthusiasts. Continuing with the email spam example, the likelihood of observing the features contains the word money feature 11 and contains the word free feature 21 given that the email is spam class 1 would be represented as P feature 11. Feature 21 class 1. Python, sklearn. From sklearn, naive Bayes import Gaussian NB. From sklearn, model selection import train test split. From sklearn, metrics import accuracy score. Load your data, replace with your actual data loading. X, your features. Y, your target variable. Split data into training and testing sets. Xtrain, xtest. Ytrain, ytest train test split X. Y, test size 0.2. Random state 42. Create a Gaussian naive Bayes model. Model Gaussian NB. Train the model. Model, fit Xtrain. Ytrain. Make predictions on the test set. YPRED model. Predict Xtest. Evaluate the accuracy. Accuracy score test. YPRED. Print F accuracy.